All right, here we go. This is number 40. The topic of this problem is total internal reflection. And let's talk first about what's happening in the problem here. There's a diamond sitting at the bottom of this pool, and there's a raft. But first, I want to just erase this raft. Let's just take the raft out and look at light rays. Get rid of the raft, and I'm going to draw in the water again. So here's the surface of the water, like that. Now, in this problem, the diamond is the source of the light rays. If you can see an object, that means that object is emitting light rays, either of its own or light rays that have been reflected off the object. But this diamond is emitting light rays in all directions, right? Light rays are coming off it in all directions. Now, if you're going to see the diamond, at the bottom of the pool, that means that a light ray that was emitted from the diamond is going to travel up to the surface between the water and the air. Now, what happens when this light ray reaches that boundary? Some of it's going to reflect back in, but then some of it, so we're going to draw in the normal line, dot, 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 that represents normal line. Some of that light is going to refract. And we know now that when a light ray travels from more dense into less dense, the refraction is going to be away from the normal, right? That's the refracted ray. Now, this is a total internal reflection problem. So the thing to realize is that as this angle becomes larger, right? So for example, instead of this ray coming like that, what if we would have focused on a totally different ray such as this, right? So this ray is also going to reflect and refract, but now the refraction is going to be what? Larger. And then what we talked about is there's a limit to how much the angle of refraction. What's the limit for the angle of refraction? It's 90 degrees. So if we call that theta 2, and that's 90 degrees, at that point, theta 1 is referred to as the critical angle. Guys, if you go beyond the critical angle, so what if a light ray hits at an angle that's even larger than the critical angle? Will any light get out? No. No light will get out. You'll only have reflection. Oh, and you know what? I forgot to mention one thing. Back this up. So to see the diamond, you should realize this. So the light ray comes up to the surface. I forgot to mention this part. So we've already said, okay, so you get reflection and then you get refraction. So if this were your eyeball right here, where would your eyeball see the diamond? What your eye does is it follows this ray here. That ray is going straight at your eye. And so what your eye does is it follows that ray back, and it's going to see the diamond like over here. Right? That's why when you look at things in the water, if you're spear fishing, it seems farther away, right? It's like you jab the spear into the water, and it's like, whoa, the fish was actually closer. You know what I'm saying? Yeah. Like you're jabbing the spear over here, but in reality, the fish is over here. That's due to refraction. Okay? So the first thing we have to do to solve this problem is figure out what the critical angle is for the water-air boundary. What is the critical angle? So the critical angle is when the refracted ray is skimming the surface and theta 2 equals 90. So what is theta 1 when that occurs? So there's an equation for this. You can derive it from Snell's law. Should I derive the whole equation?
No.
You got it? Okay, so sine of the critical angle is going to equal N2 over N1, where N2 is going to be the air, which is 1.00, and then N1 is the water, which is 1.33. You have to look that up. You should know the index of refraction for air. That's a given.
It's on the application.
Yeah, it's in a table. But even like on the AP exam, I noticed they use air a lot, and they don't give the index of refraction. You should just know what that is. So finding the critical angle, we get 1.00 over 1.33 3. So the critical angle comes out to be 48.75 degrees. Okay, so that's the first thing you got to find. Now, how is that going to help us find the diameter of the raft? So let me revert this. So what we found is this. So if we're going to see the diamond, and our eyeball is like right here, like we're on the edge of the, like right there on the surface of the water. So this ray comes up, bam, right there. Some of it reflects, and then some of it refracts. Would we see that diamond?
No.
Yeah, we would, because it's refracting. We still have refraction. So, but what if the raft were a little bit bigger than that? If the raft were that big, then what would happen? That would get blocked, and you wouldn't see the diamond. Okay, so this angle in here. So I'm going to blow this diagram up.
Wow.
So here's how you solve for the diameter of the raft. What we found is that this angle in here is 48.75 degrees. That's the maximum that angle can be. If you go bigger, you're not going to get any more refraction. You'll get 0 refraction. So this side of the triangle is 2, right? That's the depth of the pool. We're going to solve for this. I'm going to call that x. So focusing on this triangle right here, we're going to say tangent 48.75 equals opposite, which is x, over adjacent, which is 2. So x comes out as 2.28 meters, but that's going to be half the raft, correct? That's half the raft. So what's the diameter of the raft going to be? You got to double that. You double it, and you get 4.56. Yo.
How did you get like that equation, the sine of the critical angle equals?
Okay, let me show you how I got that equation. Okay, so for finding the critical angle, the ray goes up like this. Some of it reflects, some of it refracts. So when theta 2 equals 90, then theta 1 is called the critical angle. So I'm saying that the water is N1, the air is N2. So you write out Snell's law. Snell's law is N1 sine theta 1 equals N2 sine theta 2. So when theta 2 is 90, theta 1 is the critical angle. So what's sine of 90? 1. So that's where I got the equation. Sine of the critical angle equals N2 over N1. But the thing to realize here, N2 must be the smaller index. N1 must be the bigger. It's got to be bigger to smaller.